Hi guys, this week is all about factorial designs. This is when we want to combine two independent variables in the same study. We want to know what effect does each independent variable, either on their own or combined, well, how they affect the dependent variable. It sounds complex, I know, but it's really not that bad. And arguably factorial designs are much more interesting because they allow us to ask more nuanced questions about how different variables together affect each other and relate to each other. Arguably, this allows us to address more interesting questions, more real-life questions about how different variables affect our thoughts, our behavior, and our emotions. So this is where this video fits into the context of the course and the research process. I've made two videos for you this week. In this video, you'll be learning about what exactly are factorial designs. You'll be learning some terminology. And in particular, by the end of this video, you'll know what it is we're talking about when we say main effects and interactions. Before we get started, let's take a step back and situate this video in the context of what we've been talking about for the last few weeks. So for the last few weeks, we've been talking about experiments, non-experiments, quasi-experiments. Often when we were discussing this, we were talking about comparing groups of participants or a group of participants when they experience different conditions. So in an experiment, we talked about how we could manipulate one variable to create different groups or different conditions. And we would look and see what effects our independent variable has on that dependent variable. So we've given the example of when we have randomly assigned participants to either play, let's say, violent video games or non-violent video games, and to see how this impacts how aggressive kids are, let's say, during nutrition break at school. And we talked about how we can do this in a between and within subjects design. Last week, we talked about non-experiments and quasi-experiments. So in these examples, we don't have manipulation of that independent variable. Instead, we're exploring and comparing, let's say, aggression in groups of kids that already exist. So maybe we would want to see kids that themselves say they like playing violent video games versus kids that say and report that they like playing non-violent video games, and to see if there's a difference in how aggressive they are during nutrition break. The difference between a quasi and a non-experimental design is the extent to which we try to make efforts to control for that little box, that little X down at the bottom, control for outside variables to make sure that they don't become confounds. So any variable that we think could impact our dependent variable, aggression in this case, so whether the kid's parents are still together or whether they're divorced, whether they have a tendency towards being hyperactive, whether they're boys or girls, all of these outside variables could impact our dependent variable. So in a quasi-experiment, we want to control for them by matching our groups or restricting the range. In a factorial design, rather than, controlling for it by, only testing girls, let's say, and testing girls that are assigned to play violent video games and girls that are assigned to play non-violent video games. In a factorial design, we can combine those outside variables and see whether they themselves have an impact on our dependent variable. So a factorial design means that we're combining multiple independent variables in the same study to look to see how those multiple independent variables affect our dependent variable. So in a factorial design, we have still that one dependent variable, but we have multiple independent variables. So let's give you a bit of terminology. It's called a factorial design just because it's easier to say factor than independent variable. So whenever we have more than two independent variables, we instead call them factors. So a factorial design is a research design that includes two or more factors. And we can have lots of different factors in the same design. A single factor design has one independent variable. That's what we've been talking about up until this week. A two-factor design has two independent variables, and we can give it a new notation here depending on the number of levels in each of our factors. So a 2x2 design, let's say, would be comparing kids who are playing violent video games versus non-violent video games, as well as comparing girls and boys. This would be an example of a 2x2 because we've got two levels of each of our independent variables. But this can get really complex if we want it to be. We can compare three groups of kids on two different conditions. We can compare three groups of kids on three different conditions. We can even have a three-factor design where we have three independent variables. So a 2x2x2 design would be, let's say, I don't know, you could think of an example maybe of this: girls and boys, violent versus non-violent video games, and whether they play, I don't know, before school or on the weekends, let's say. So we can make this really complex if we want to. As a side note, we probably don't want to go too far out there because, you know, each of these multiply, right? So a 2x2x3 design, for example, has a total of 12 different conditions. If we needed 30 participants in each group, whoa, that would be a lot of participants. All of this is to say is that we've got a lot more flexibility and room to design the study in the way that we'd like to. So in a factorial design, we've got multiple factors. They can be experimental, non-experiment, or quasi-experimental. The main advantage of a factorial design is it can create a much more realistic situation than we have when we only look at each factor in isolation. And the other major benefit is that we can see how those factors impact our dependent variable in the same study, but also how they work together to impact our dependent variable. And I'll show you what we mean about that in a second. The disadvantage, of course, is that it's more complex, but we can handle that. All right, let me give you some examples. Working from this example of video game playing and whether there is an impact on kids' aggression depending on the kind of game that they play and whether they're a boy or a girl. Your textbook uses this example too. So let's say we wanted to do this. We would recruit maybe 60 boys and 60 girls. We would randomly assign our boys to either play violent video games or non-violent video games, and similarly do the same for the girls. 30 girls would play violent games and 30 girls would play non-violent video games. And then all of our participants, we would measure how aggressive they are after playing these different video games. So here's a question for you to see if you're following along. Imagine we had this design and we wanted to see how aggressive kids are depending on whether they played violent video games or non-violent video games, and if there was a difference depending on whether the kids were boys or girls. What are our independent variables in this study? Why don't you pause the video here and see if you can answer this question. Okay, hopefully you paused it. The answer to this is A. Those are our two independent variables. Aggression is our dependent variable. So let's talk now about main effects and interactions. A two-factor design where we have two independent variables can be represented in this kind of matrix where we've got columns and rows together. Our levels of our first factor is represented by the columns, so whether there's a difference in aggression depending on if you're a boy or a girl. Our levels of our other factor is represented by the rows, whether there's a difference in aggression depending on whether you play those violent games or the non-violent video games. And each of these boxes or cells, if we use that terminology, is the average score for each of our groups of participants. So the data that we get from this gives us three separate and distinct sets of information that allows us to answer whether each of our factors, either independently or combined, impact our dependent variable. So here are some terms that you should know. The main effect is the average difference between levels of a particular factor. So a two-factor study has two main effects. We'd be, in that previous example, we'd be looking for the effect of gender on aggression, and we'd also be looking for the effect of video gaming on aggression. An interaction occurs whenever one factor has a direct influence on the effect of the second factor. So in our example of video game playing, we want to see whether video game, having violence in your video game has a different effect on boys versus girls. You might also think of an interaction, maybe this is more intuitive, if you think of like drug interactions where one drug can modify the effect of another drug. I don't know, for example, if you've ever had a few drinks after you've taken antibiotics, the effect of the alcohol is much stronger depending on whether you're taking antibiotics or not taking antibiotics. So this is an example of an interaction where our feeling of drunkenness is different depending on levels of that one of our independent variables. Taking antibiotics versus not taking antibiotics, drinking alcohol versus not drinking alcohol. When you combine them together, the effect is greater than on their own. But all of these there's multiple different outcomes that can happen. Independent factors are ones that have no interaction. So it doesn't depend on what level of the other variable you have to show your effect. So if let's say you're immune to the effect of your antibiotics, just wasn't working for you, then we wouldn't have an interaction. The effect of alcohol would be independent. It wouldn't interact with the antibiotics. I'll give you some more examples. I think this will become clear in a second. So let's use this example again of video game playing, violent versus non-violent video games, and girls versus boys. So two independent variables. Our dependent variable is how aggressive they are in nutrition break. We've randomly assigned 30 boys to play the different games, 30 girls to play the different games. We're measuring aggression in each of our participants. We get an average for each of our 4 groups. This is the average aggression level in boys that play violent video games versus boys that play non-violent video games, similarly for girls. So we can look for 3 different things here. We can look to see whether there's a main effect of playing violent versus non-violent video games. So to do that, we would take the average of these 2 boxes right here and the average of these 2 boxes right here, put them here. And we would look to see if this result is larger or the same. So here we can see that on average, playing violent video games, kids are more aggressive than when they play non-violent video games. This would be an example of a main effect of game type. Similarly, we can also look to see if there's a main effect of gender by looking at how aggressive boys are and how aggressive girls are. We're collapsing across the different game types that they play to get an overall average for boys and an overall average for girls. We'd see that boys are overall more aggressive than girls, so we've got a main effect of gender here. But we can also look for an interaction and to see if the kind of violent games or non-violent games that kids play has a bigger effect on boys versus girls, and we can see that this is the case. So if we look and see what is the difference between this box and this box, and look to see if this difference is different than this difference, then this would suggest that there is an interaction. Similarly, if we look at the difference between these 2 numbers, 9 versus 2, and see if that's different than 4 versus 2, it is different, so this suggests there's an interaction. So to identify an interaction in a data matrix, we need to look to see if the size and direction of the difference in one row is the same as the corresponding difference in the other row. If they are the same, then this would suggest that there is no interaction, that those main effects are working independently of one another. If that difference changes from one row to another, like we saw in that last example, then that would suggest that there is an interaction. And we would need to do stats to see if that interaction and those main effects really are statistically meaningful. It's much easier to see interactions when we graph them. This is why graphing is so important in quantitative research methods. By graphing, we can take a look and it just pops out. That interaction will pop out at you. If we plot them as in a line graph, we'd be looking to see if the lines are parallel or not. Non-parallel lines suggest that there is an interaction. Parallel lines suggest that there's no interaction. So I'll show you what that would look like here. So this is the same data from that little matrix, those boxes, plotted here in a graph. So on the y-axis, we have the how aggressive kids are. On average, the number of aggressive acts that they do. This beige line are boys, the blue line is girls. Over here on the left, we have when those kids played non-violent games versus when they played violent video games. So we can say three different things from looking at this graph. We can compare boys and girls. So we can compare the overall blue to the overall beige, get an average somewhere in the middle and say boys are more aggressive than girls. We can also look for a main effect of our video game playing by looking at, you know, the average of these two circles and the average of these two circles. It'll be somewhere in here and somewhere in here. We can say that there's a main effect of game playing, but you can also see that the lines are not parallel. This suggests that there is an interaction. For girls, it really doesn't matter what kind of game that they're playing. They're not going to be very aggressive in this data. Versus with boys, boys are more aggressive overall, but they become even more aggressive when they play violent video games. So this suggests that there's an interaction between our two variables. So if we wanted to ask, if this was our research question, are kids more aggressive when they play violent video games? The answer from this data would be, or these data would be that it depends. Boys are more aggressive when playing violent video games. Girls are less aggressive overall, and they don't seem to be impacted by the kind of video games that they're playing. So a factorial design where we're combining multiple independent variables together by adding gender as a variable to our study, we get a more nuanced and arguably more accurate answer to our research question. And here is a photo from your textbook showing that same result in another graph. This is a bar graph. And again, you can see that there is an interaction because these bars are the same height over here, but they're a different height over here. All right, so I'm going to give one more example of a factorial design, one that maybe is relevant to you to illustrate what we're talking about when we talk about main effects and interactions and the ideas that the main effects can be independent from one another. Let's use an example that's maybe a bit more relevant to you this year. Imagine we are interested in how your learning has been affected by the way you've been learning this year. And so we wanted to know whether lecture format impacts exam scores. We wanted to know whether exam scores differ depending on whether students are learning in class versus online. This would be an example of, you know, a between subjects design if we were able to randomly assign people, or it could be a differential non-equivalent group design if we weren't randomly assigning people to these different groups. But let's say that we didn't want to leave it just on there because we had a feeling that the answer was a little bit more complicated. It doesn't just depend on the format of the lecture. Suppose we also had a feeling that the impact of this lecture format is going to have a greater effect depending on your own studying style. So let's say we also wanted to investigate the way you study and whether that impacts your exam scores. So maybe we'll have two groups of students. One group of students, we'll call them extensive studiers who do lots of practice questions, make their own notes, reviewing throughout the course, versus students that are more surface studiers who just read the text and watch and attend lectures or watch the videos. So our research question is more nuanced. We want to say, does lecture presentation mode affect your exam score? Does the way that you study impact exam scores? Are there main effects of these two variables, and do these two variables interact with one another? So why don't you pause the video here and see if you can answer these questions. What are the factors in this design? How many levels are there of each? What are the dependent variable? What kind of design do we have? And pause this video, and I won't give you the answer. It's written in the slides at the bottom of, in the notes section at the bottom of these slides. Another way that we could phrase this is, what kind of factorial design do we have? Why don't you pause the video and see if you can answer this multiple choice question. I'll give you the answer to this one. This is a 2x2 design because we're comparing two independent variables, each of which have 2 levels. So a 2-factor study allows us to evaluate 3 different mean differences: the effect of factor A, the lecture format, the effect of factor B, the study style, and whether there's an interaction between our factors. If we just looked at the main effects on their own, we might not get a real accurate picture of what is actually happening in the real world. It's only by looking at the interaction between the factors can we truly understand how variables are working together to impact a dependent variable. And this phrase, interactions trump main effects, is horrible now in the context of Donald Trump. But the idea is that whenever we have an interaction, that is the conclusion that we draw from the study. That is more important than any of the main effects on their own. So I'm going to give you some examples using line graphs, using this example of what it would look like if we had main effects and no interaction. So here we'd have exam scores on the y-axis. We'd have different lecture styles, whether it's in class or online, and we have different study styles, whether you're an extensive studier or a surface studier. You can see here that we'd have a main effect of study type. Extensive studiers tend to have, according to these results have higher exam scores than people who are more surface studiers. We also have a main effect of lecture presentation. In class seems to be better than online, and there's no interaction. We get a similar pattern. The effect of in-class versus online learning is the same for both kinds of studiers. This would be an example of the same data where there is an interaction. So we again see a main effect of study type. This group performs better than this group. We can also see a main effect of the lecture format. In class is on average better than the online format because that would be an average of these two. But if we just looked at each main effect on their own, we'd be missing this main interaction, which is the more nuanced and interesting finding that it depends. The answer to how do these factors work together, they do. And the effect of, in this example, the effect of lecture format is much greater and much more detrimental to the surface studier group than the extensive study group. For these students, it doesn't matter how the lectures are presented. They're going to do really well, versus for these students, having online lectures is harder for them to do well than in-class lectures. So in a 2-factor study, researchers can evaluate the main effect of factor A, the main effect of factor B, and whether there's an interaction between them. And I think this is the same slide that I just showed before, so I'm just going to skip over that. In a 2x2 study, there are 8 possible outcomes. One, for example, I just gave you 2 of them where there's a main effect of both factors and either an interaction or no interaction. Why don't you see as a review activity if you can list all 8 possible combinations that can come from a 2x2 study. And we'll leave it there, and I'll see you at the next video. Oh, if you want to find the answer to this, I'll post it in another set of lecture slides on Sakai, and we'll talk about what those 8 possible combinations mean, answer any questions you might have at our next meeting. That's all for this video. We'll see you next time.